We're handing large language models the job of translating raw probability into plain English for high-stakes decisions. But do they actually understand likelihood and uncertainty, or are they just pattern matching? A recent study put 9 LLMs to the test. The goal was simple. Can models consistently and accurately map numerical risk to natural language descriptors like very likely or highly uncertain? To find out, researchers simulated predictive distributions using a beta function. They parameterized it with 2 values: the mode, which controls likelihood, and the prior sample size, which controls uncertainty. Each model was prompted across 6 real-world domains and 10 different temperature settings. They measured 2 core metrics. Consistency tracks whether identical inputs produce identical outputs. Calibration checks whether the chosen descriptor correctly tracks the numerical magnitude. For calibration, they used a modified Jenkier-Terpstra trend test, which statistically verifies if descriptor choices follow the correct numerical ordering, while penalizing models that avoid certain terms. The results were stark. Models were generally consistent, but fundamentally miscalibrated. GPT-5.4 broke the pattern with near-perfect likelihood calibration, showing a deterministic mapping between distribution mode and verbal descriptors. But across the board, uncertainty verbalization collapsed. Even top-tier models defaulted to vague, moderate terms regardless of the actual mathematical spread. Cranking up the temperature traded consistency for slightly better calibration, and feeding the model's precomputed parameters didn't fix the core issue. That tells us the bottleneck isn't statistical inference, it's the verbalization step itself. Right now, LLMs lack a stable internal mapping for probabilistic language. They're fluent but not faithful. For risk communication to be reliable, we can't just rely on zero-shot prompting. We need targeted interventions at the language generation layer. The full methodology and code are open source for anyone who wants to dig into the ablations.